We talked about Lewis structures for ionic compounds on Tuesday, and so now we're going to talk about what happens for covalent compounds. Covalent compounds form between metals and nonmetals. I'm sorry, that's ionic compounds. Covalent compounds form between nonmetal elements. When nonmetals bond with other nonmetals, we get molecular or covalent compounds. The electrons are shared. The word covalent is sharing valence electrons. And in Lewis theory, we represent the covalent bonds by having neighboring atoms sharing some of their valence electrons in order to obtain octets. So let's look at the Lewis structures for hydrogen and oxygen. So hydrogen is H. And how many valence electrons does hydrogen have? How many electrons does hydrogen have? One. It only has one electron. So it has one valence electron. And then we have oxygen. How many valence electrons does oxygen have? Six. So remember how we're doing this. We're seeing that oxygen is in group 6A in the periodic table. It's got 6 valence electrons. When we did electron configurations, oxygen has electrons in this it's in the second period, so it's got 2s2 and 2p, 1, 2, 3, 4, 2p4. So 2 plus 4, 6. So we're going to represent this as 6 dots around the oxygen. That's the Lewis structure for oxygen. So Lewis theory tells us that the atoms are trying to get an octet. These are going to share electrons so that each atom gets a duet and the oxygen gets an octet. What happens when hydrogen gets a duet is it has the same noble gas configuration as helium. And remember, the noble gases are especially stable electron configurations. Oxygen wants to also gain some electrons and form an octet of electrons and be like neon. But because these are both nonmetals, they both want to gain electrons. And so, the hydrogen's saying to the oxygen, hey, give me one of your electrons so that I can have 2 electrons and look like the cool guy helium. And the oxygen says, no way, I'm trying to get electrons too. Why don't you give me your electron? And then I'll be closer to looking like neon. And no one is willing to give up an electron, and so they share instead. So what happens is the hydrogen and the oxygen will each share an electron with the other one. And when you're sharing with someone, the shared item belongs to both of you, right? My husband and I have 6 children. And yes, they're all ours. And if you ask him, how many kids do you have? He'll say 6. They're his kids. You ask me, how many kids do you have? I'll tell you I've got 6. They're my kids. How can they belong to both of us? Because we share them. Same thing works with electrons. When these electrons are shared between the hydrogen and the oxygen, they belong to both of them. So now when hydrogen looks at himself and says, well, how many electrons do I have? I got 2 electrons. So we could draw a circle here. This is what hydrogen feels belongs to him, or her, depending on. Hydrogen's kind of a funny guy. And oxygen now is going to look at these electrons and say, hey, this is better. Now I've got 7 valence electrons. But is oxygen happy yet? No. Oxygen wants 8. So oxygen's going to come up next to another hydrogen atom. There's another hydrogen atom out looking for an electron. And these guys are going to share also. So now this hydrogen has a duet. It has 2 valence electrons. Remember, hydrogen is small. He has low aspirations. He's just trying to look like helium. And now oxygen looks at all of these electrons, and we've got 2, 4, 6, 8, an octet of electrons. By sharing, oxygen can make up for this deficiency in its electron configuration. Any questions? So here's a fancier picture of what I drew. So here's the oxygen, and because of the sharing going on with this hydrogen and the sharing with that hydrogen, this oxygen now has an octet of electrons. Each hydrogen has a duet, 2 electrons. And the reason that water forms from 1 oxygen and 2 hydrogen atoms is because when they get together in that ratio and share electrons, they can satisfy the octet and duet rules. And the reason that's important, those are lower energy. It's like a discount. If some of those discount deals, it's like you have to jump through hoops and hop on one leg. It's like, wow, the planets have to align to get this deal. But when 2 hydrogens and 1 oxygen share, they're getting a great deal. Okay, it's lower energy than either of them by themselves. And so that's why it will go together like that. It's all about energy. And of course, the whole energy concept is much, much more complicated than that. But at this level, it's enough. When they share electrons to have octets, then it's lower in energy, and that's a good thing. I think it's easier to think of them being happy, but obviously atoms can't be happy, except in chemistry land. In chemistry land, anything's possible. So if we look at this Lewis structure for water, there are 2 different kinds of electrons in here. This pair of electrons between the hydrogen and the oxygen is called a bonding pair. Those are the electrons that are being shared. There's another bonding pair right here. There are also 2 pairs of electrons that are just on the oxygen and they're not being shared with another atom. These are called lone pairs because they're alone. They're just on the one atom. So we have lone pairs and we have bonding pairs, and we need to know the difference. Sometimes when we draw a Lewis structure, we will show the bonding pairs as a line. So this line represents a covalent bond. A covalent bond is 2 electrons being shared between 2 atoms. And these dots are the lone pairs on oxygen. You need to remember that those lines represent 2 electrons. So if we do the Lewis structure again, it's like connecting those dots. It's like taking the shared electrons and playing connect the dots with them. Any questions? The Lewis structure can be just the dots, or you can do it with lines. Yeah. A Lewis structure, the key factor is that we're showing the electrons, especially the lone pairs, as dots. The bonds, sometimes it's clearer and more efficient to use lines. And so you kind of have to look at what the question, if it's a homework question, what's the question asking for? Personally, if I ask you to write a Lewis structure, I would accept either of these. You can do the dots or the lines as far as I'm concerned, okay? But we're showing the electrons, all the bonding electrons and the non-bonding valence electrons. We said that bonding theory explains why molecules form. We talked about diatomic elements, right? There's 7. Nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen that form molecules of 2 atoms when they are the element not interacting with another element. And so why does that happen? Well, Lewis theory helps to explain that. So let's look at bromine. Bromine is a diatomic molecule as an element. So here's one bromine atom, and here's another bromine atom. How many valence electrons does bromine have? 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Remember, we're making these dots on the top, the bottom, the right, and the left. So you can kind of envision it being a square, right? And this is where the electrons can go. So what can these two bromine atoms that each have 7 valence electrons, what can they do so that they can get an octet? They could each share an electron with the other one, right? So if we share that, and I'll just draw a line to indicate that we're sharing those, now this bromine counts both of the shared electrons as belonging to it. 2, 4, 6, 8. Octet. Bingo. That's what we're looking for. And this other bromine atom also counts the shared electrons. 2, 4, 6, 8. Octet. Everybody's happy. That's what we're trying to do. Drawing Lewis structures, we can make everybody happy. I wish life was that simple, but it isn't. Lewis theory also predicts that hydrogen exists as diatomic molecules. Let's look at hydrogen. Each hydrogen atom has 1 valence electron. And what is hydrogen trying to get? 2. It's trying to get the electron configuration of helium, which is 2 electrons, 1s2. And it can do that by sharing an electron with another hydrogen atom. This one now counts both of the shared electrons as belonging to it, and the other one also counts those 2 electrons as belonging to it. Occasionally students are bothered, how can you count them twice? Well, it's like the children. I have 6 children, my husband has 6 children. Does that mean there are 12 children in my house? No, because they belong to both of us. They belong to me and they belong to him. Thank goodness. There's not room for 12, definitely. Any questions? Atoms sometimes share more than 1 electron in order to get an octet. Let's look at oxygen. Oxygen is a diatomic element, right? Oxygen has 6 valence electrons. So we've been learning that 2 atoms can share an electron to increase their number of valence electrons, and so we could have an oxygen sharing an electron with an oxygen. Does this satisfy the octet for each of them? No. It's closer, but this oxygen has 7, right? 2, 4, 6, 7. And the other one also has 7. So that's not good enough. What they can do is they could share another pair of electrons. So now it's going to count all the shared electrons and its own lone pairs, 2, 4, 6, 8. And the other one also has 8. Now that's kind of an ugly Lewis structure, but that might be something that you would write down as part of figuring out what you're doing. And
all of them do that, or just oxygen?
well, all of the large enough ones, you know, the very smallest ones are only trying to get 2 electrons, and so they're never going to form double bonds. Most of the larger nonmetals can do double bonds, but they only do it to get an octet. So like with the bromine, it's not going to make a double bond because a single bond is enough, and now it has an octet. Having 9 or 10 electrons is not a good thing. It has to be 8. Does that answer your question? Kind of? Yeah, let's just keep going, and hopefully it'll clear up. So let's draw this a little neater. So using lines, I would represent the double bond with a double line. And then I would put, there's 2 lone pairs on each of those atoms. Or I could do it entirely with dots. And here I would show 2 pairs of dots being shared. This one has 2 lone pairs, and this one has 2 lone pairs. What's important is that we have the correct number of electrons involved here. Each oxygen has 6 valence electrons. So when I drew this initial structure with 6 valence electrons, I can't add or subtract dots after that. We can share them, we can move them around, but we can't make them disappear, and we can't just bring in and write new ones. So either of these would be good Lewis structures for oxygen. Oxygen forms a diatomic molecule by making a double bond between 2 oxygen atoms. Any other questions? So a double bond is when 2 electron pairs are shared. Double bonds are shorter and stronger than single bonds. If you look at a single bond between 2 oxygen atoms, the length of it is 148 picometers. If you look at a double bond, the length is shorter. It's 121 picometers. When there's a double bond, those oxygen atoms are closer. They're closer together, that bond is stronger. Let's look at nitrogen, another diatomic element. Let's not use the marker. Nitrogen, how many valence electrons for nitrogen? 5. 1, 2, 3, 4, 5. And 5 for this guy. I'm drawing them as mirror images just because I'm anticipating what I'm going to do with them. And like I said, exactly where you put the dots doesn't matter as long as you stay to the top, bottom, right, and left. Single first and then pair them up if needed. So here we have 2 nitrogen atoms, and they're going to try to share electrons so that they can each have an octet. So let's start out by sharing this one. Does that give each of them an octet? No. Well, then we need to share some more. Let's share these guys. We're getting closer, right? Each of them has 7 now. This shared electrons count for each. So this nitrogen over here counts 2, 4, 6, 7. So what we need to do is we need to share another pair of electrons. Now the bond here, the 3 bonds count for both nitrogens. So this nitrogen counts the 2 lone pairs, and 2, 4, 6 for the bonds. 6 plus 2, 8. Same thing for the other one. So let's clean that guy up a little bit. This is called a triple bond. So this is a good Lewis structure for nitrogen. We can also draw it just using the dots. I think I can. So in order for 2 nitrogen atoms to get together and form an octet for each of them, which was going to be a stable molecule, it needs to have a triple bond, 3 pairs shared. It would stop at 1 if that was enough. An atom with 8 valence electrons to start with is not going to make any bonds. That's why the noble gases form almost no compounds, because they have an octet. And of course, there are exceptions to Lewis theory, but we're going to avoid talking about them as much as possible. That's what we can do in intro chemistry. So that's called a triple bond, when 3 pairs of electrons are shared. So those are pretty convenient names. Single bond, a single pair. Double bond, a double pair. Triple bond, a triple pair. Triple pair. Triple pairs. So the triple bond, as we might imagine, is even shorter and stronger than a double bond. If we look at nitrogen, the triple bond has a length of 110 picometers. The double bond is 124. When you go from a double bond to a triple bond, the distance between the atoms gets smaller. The bond is shorter. Because nitrogen has this very strong triple bond, nitrogen is a very inert molecule. Oxygen has a double bond, but it will burn. Hydrogen is much more reactive than oxygen. It has a single bond. Nitrogen with that really strong bond is much more inert. Nitrogen doesn't burn. Because in order to get that nitrogen atom with the triple bond to react, you have to break at least one bond of that triple bond. And that's not as likely to happen.